Welcome to the deep dive. You know, when you open a terminal and type a command to run a script, you are not casting a spell.
Right. Not at all.
You're not like asking the machine to do you a favor. You are firing off a highly specific, notoriously stubborn set of instructions.
To a processor that is, well, entirely devoid of intuition.
Exactly. So whether you are prepping to learn how to code or you're just insanely curious about how the digital world operates under the hood, programming isn't actually magic.
It really isn't. I mean, it's just a highly specific way of giving instructions.
Right. So today our mission is to translate the foundational building blocks of programming. We're looking at a set of CS50 notes on Introduction to Programming with Python.
It's a great foundation.
It is. And we are going to demystify functions, variables, and really look at the core syntax that makes software tick.
And, setting the stage here, learning Python is less about memorizing jargon. It's more about learning a completely new way to structure your thinking.
Yeah, you stop fighting the language and start utilizing it. Okay, let's unpack this. We have to start right at the ignition point.
Very beginning.
Right. You type python hello.py into your terminal.
Mm-hmm.
If running that file is sort of like hitting the start button on a machine, then a function is basically a verb.
Yeah, that's a really good way to look at it.
Like the word blend on a blender, and the arguments you pass to it, those are the nouns. They're the fruit you actually put into the blender.
That is a perfect analogy. You're mapping an action to an input. But when you are giving a computer these literal instructions, you also run into bugs.
Oh, the dreaded bugs.
Right, because the computer takes your instructions so literally that any tiny typo, any misplaced character, it just becomes a bud.
It has no idea what you meant to say.
Exactly. Your instructions just have errors. But beyond just bugs, there is this really nuanced concept in the notes called side effects.
Okay, what is a side effect in this context?
Well, sometimes a function does something visible to the user, like printing a message to a screen. That is actually a side effect of the function running. It's an action it takes rather than the core data it hands back to the program.
Wait, really? Just showing text is a side effect?
Yeah, it's altering the state of the display.
Yeah.
Which makes you wonder, what stands out to you about the idea that computers take instructions so literally that any tiny typo becomes a bug?
I mean, it forces you to be hyper-intentional, which actually brings us to looking under the hood of a function.
Let's do it.
Because we just talked about functions as verbs, right? So let's look at one of the most common verbs in Python up close, the print function.
The one everyone starts with.
Yeah, but if you look at the source notes, they point to the official documentation at docs.python.org.
Right.
And if you go specifically to docs.python.org/3/library/functions.html hashprint.
This is a dense page.
It looks like complete gibberish at first glance.
Yeah.
The syntax they show is print, and then in parentheses, star objects, sep equals a space, end equals /n, file equals sys.cdout, flush equals false.
It is definitely a lot to take in.
Yeah. It is. So I have to play proxy for the listener here and ask you to translate that.
Well, what's fascinating here is that we are looking at the parameters of the print function.
Okay, the parameter.
Yeah, the default rules as follows. For instance, sep equals a space tells the computer how to separate words. By default, it just puts a space between them.
Oh, so you could change that to a comma if you wanted.
Exactly. And then end equals /n tells it to hit enter or make a new line at the very end of whatever it's printing.
Wow, so even just making a new line isn't magic. It's an explicit instruction.
It's all explicit. And then you have file equals sys.cdout. That tells Python to treat your computer screen, your standard output, basically as a file that is writing to.
That is wild. And what about flush equals false?
That's an optimization trick. Writing to the screen takes processing power, so Python waits until it has a full chunk of text before it flushes it to the screen all at once.
It's brilliant because it hides all that complexity from beginners.
Right. But the bigger picture here is that no programmer memorizes all of this default syntax.
They don't.
No way. They rely entirely on the official manual. That's why knowing how to reference docs.python.org is so important.
Here's where it gets really interesting, because now that we know how to make the computer do things with functions, we need a way to remember the things we are working with.
Right, we need to store information, the nouns.
So we use variables,
Yeah.
and usually variables get compared to like labeled moving boxes.
Yeah, that is the classic beginner analogy.
You put data in the box, you write a name on the outside.
Yeah.
But I have to push back a bit here. Does the computer actually care what is in the box?
Oh, it absolutely does. This is where we get into data types.
Okay, so it's not just a generic box.
No, not at all. The hardware needs to know exactly what it's dealing with
Huh.
to allocate memory. So you have an int, which is short for integer or a whole number,
Right?
and then you have a float, which is a floating point number, basically a decimal.
But why separate them? Isn't a number just a number?
Mathematically, yes. But computationally, representing a whole number versus a decimal requires completely different hardware logic. Floats can actually cause precision errors if you aren't careful.
Because the computer's estimating the decimal and binary, right?
Exactly. And then, completely different from numbers, you have string, which is short for string.
Programming speak for text.
Right. And the notes point out that strings have their own very specific behaviors. If you check the documentation under string methods, you'll see actions you can only perform on text data,
Like what?
like changing a whole sentence to uppercase. You can't uppercase the number 5, right? That method only exists for strings.
That makes total sense.
Yeah.
So we have our variables, these boxes of numbers and text. What happens when we want to combine or manipulate them?
Well, then we use math operators.
Right, and most of them are totally obvious, like, the plus sign, minus, asterisk for multiplication, slash for division.
Very straightforward stuff.
But then the notes highlight the percent symbol, and I have to ask, why is a percentage sign in the math operators?
Yeah. That is not actually a percentage sign in Python.
Wait, really? What is it?
It's the modulo operator.
Modulo. Okay, what does that do?
It finds the remainder of a division problem.
Oh, like when you first learn long division in elementary school.
Exactly. It's a crucial pattern-finding tool in coding. It lets you figure out if a number is even or odd, or help you wrap around a list of items.
That is super useful. The notes also mention the round function for math.
Yes, round is great. It takes a number, and optionally you can give it an indigits parameter.
And digits, like number of digits.
Right. It allows you to specify exactly how many decimal places you want to keep, which is super helpful for those floating point precision issues we talked about.
But, writing a massive program all at once just to test if a modulo or a round function works sounds awful.
It is. You don't want to do that.
Which introduces the aha moment of this section, interactive mode.
Yes, the REPL.
It's like a scratch pad. You can type these math operators and functions line by line and get instant feedback.
It's immediate. You hit enter, it runs the code and shows you the result right there. You don't have to write a whole script.
So we've been using Python's built-in verbs so far, things like print and round.
Right, the tools they give you out of the box.
But the real power of programming comes when you start inventing your own rules, doesn't it?
Exactly. You become the architect.
Ah.
And you do that using the def keyword.
Def, like D-E-F.
Right. It literally defines a new custom function. You get to name your own verb and tell the computer exactly what steps to take when that verb is called.
Okay, so I define my own verb.
Yes. And once your custom function does its job, it uses a return statement.
A return statement?
Yeah, it's how your custom function hands the final answer back to the main program. Those are called return values.
Okay, but I have a critical pushback here.
Sure. What is it?
If I create a temporary variable inside my custom function just to do some intermediate math,
Right.
does the rest of my program know about that temporary variable?
Well, this raises an important question, and the answer is no. This introduces the concept of scope.
Scope. Okay, explain that.
Scope is essentially the Vegas rule of programming. What happens inside the custom function stays inside the custom function.
I love that. So the main program can't see those internal variables at all.
Not at all. And that is by design. If every part of your program could see every temporary variable you ever created, you would accidentally overwrite things constantly.
It would be total chaos.
Complete chaos. So scope acts as a quarantine. When the function finishes and returns its value, all those temporary variables just disappear.
So what does this all mean? Because with all these custom functions and scope and modulo math, this code can get really complicated really fast.
Oh, it can become totally unreadable if you aren't careful.
Right. So how do we keep from just confusing ourselves and our teammates? Because coding isn't just about talking to a machine.
Not at all.
It's almost more about communicating with future versions of yourself.
Yes, if we connect this to the bigger picture, it is all about humanizing the code.
Okay, how do we do that practically?
The notes mention two critical practices, pseudocode and comments.
Pseudocode. That's like fake code.
Exactly. It's planning out your logic in plain English before you write a single line of actual Python.
So you're not worrying about commas and brackets yet?
Right. You're just mapping out the steps. Because if you can't solve the problem in plain English, you definitely can't solve it in Python.
That makes a lot of sense. And then what about comments?
Comments are notes left directly inside the code file, but the computer entirely ignores them.
So they are purely for humans to read.
Yes. And a big trap beginners fall into is writing comments that explain what the code is doing. But you can already see what it's doing by reading the code.
Right. If it says +1, I know it's adding 1.
Exactly. The best programmers spend their time commenting on the why. Why did they use this specific function? Why did they structure it this way?
It's leaving breadcrumbs for whoever has to read it later.
Even if that person is just you 6 months from now.
Because you will absolutely forget why you wrote it that way.
You definitely will.
So to quickly recap our journey today, we started with running a file and understanding that functions are verbs and arguments are nouns.
Right.
We dug into the official documentation to see how complex a simple print command really is.
Looking at those default parameters.
Yeah. We define variables not just as boxes, but as specific data types like integers, floats, and strings.
Mm-hmm.
And finally, we wrote custom code with def, managed our scope, and kept it all readable with pseudocode and comments.
It's an incredible toolkit.
Okay.
And, I want to leave you with a final thought to ponder.
Yeah, please do.
When you write pseudocode, or when you leave detailed comments, you are forced to break down your own subconscious thought processes into explicit, unambiguous steps.
Because the computer can't guess what you mean.
Right. So learning Python isn't just about teaching a rock filled with lightning to do math.
I love that phrase.
It's actually a mirror. It shows you exactly how you think and how you solve problems. You are learning about your own cognition.
Wow. You're mapping your own mind in plain text. That is a fascinating way to look at it. Thank you so much for joining us on this deep dive. Keep questioning the digital world around you, and we'll catch you next time.